Assalamu alaikum. My name is Ahmed, and my roll number is 231804. Today, this is my project, Bingham flow and pressure drop in 3D concrete printing. In this project, I reproduced an analytical model presented by a research paper. Okay, and we have used MATLAB for the simulation. Now, here are a few values that we have implemented and taken from the research paper. Here I implemented the tapered tube analytical equation using the parameters from the research paper, including 25 mm inlet radius, 20 mm cone length, 15-degree taper angle, and 50 Pascal per second plastic viscosity, and yield stress of 500 Pascal. Now, when we run the code, uh, after running the code, here is the command window that shows the result. And here it shows that we have available Hmax 564, and here are other few values that we are going to check and compare with the research paper we have selected. So here is the output simulation of the MATLAB. This is the figure 1, the comparison, the graph between taper angle and the cone pressure, and we have few more graphs. First, I will show you the report. Here is the report I made using the research paper, and we have used this research paper. This is DOI of the research paper, and now if I this is the first output we got from the MATLAB, okay, and this was the graph between taper angle and the cone pressure, and this is the graph between like design and sensitivity and pressure drop, condition and pressure drop basically, and the third graph we got is the graph between head and required cone or throat available, okay, and the last graph is between the yield stress and the pressure margin. Now here are the corrected validation errors. Now we have compared the output of the research paper and our MATLAB simulation, and we have the 0% percentage error between the output of the research paper and our MATLAB results. Now first we have got 53.3323% of percentage error, but we have reduced it to 0% by correcting, because this factor was causing the percentage error. 100 factor of 100% difference between the engineering flow rate and the paper validation flow rate. Now here the tabular form of of the values we got and the comparison. It's a graphical representation that shows the percentage error at 0°, 5°, 15°, and 30°. So that's my report that shows all the graphical output of MATLAB and the percentage error.